right, let's sketch this first example curve. So first thing you're supposed to do is figure out the roots, intercepts, any asymptotes. So let's figure out the roots. So we can factor out an x. Let me get white here. We can factor out an x, and we get x squared minus 12. So we know that x equals 0, and x equals plus or minus the square root of 12, or plus or minus 2 square root of 3. So if we were going to sketch this just using end behavior, we could. So let's just make that 2 square root of 3 and negative 2 square root of 3. And it is a cubic function, and so we know that and it's positive, that it has to come down through 2 square root of 3, go back up through 0, and come back down through negative 2 square root of 3. So that gives us a good idea how to sketch it. We just need to find these points, and we'll be pretty well done. And I guess figure out concavity, but since I know it's a polynomial function, that's a pretty easy one to figure out. So there's no asymptotes. All right, so let's take the first derivative. That's the first thing you would do. Second thing you would do, I guess. 3x squared minus 12. Set that equal to 0. Factor out a 3. You get x squared minus 4. So you get x equals, well, that's x plus 2. Difference of squares, right, guys? Whoops, x minus 2. Minus 2. Equals 0, so you have plus or minus 2. So there's 0, here's negative 2 and 2. And let's use end behavior. This is a polynomial that's degree 2 when we took the derivative. And so it's a parabola. It would be facing up, so we would do like that. This is not the graph, this is the derivative of the graph. So we know it's positive here, positive here. So that means at negative 2, we have a maximum because it goes from positive to negative. And at 2, we have a minimum. Now we don't know what those are, so we can find out what they are by saying, putting it back into the original to find. So now, if I'm sketching this, I have 0, and then I have 2, and I have 2 square root of 3, and I have negative 2, and I have negative 2 square root of 3. And I know it goes through 0, and it goes through these points. So those are my zeros. And I know that at negative 2 and 2, there's a maximum at negative 2 and a minimum at 2, and I just need to know how far up and down that is, or the y value. So in the original equation, putting in a negative 2, I get negative 8 plus 12, plus 24, sorry, equals 0. So I get negative 24 minus 8 is 16. So at 16, I have a max. So let's just make this positive 16. So I put a point right there at negative 2. And if I did it with a positive 2, I would get, let's put it back into the original, I would get 8 minus 24, which is negative 16, which is, since it's symmetric, I knew that. And so let's put negative 16 down here. So there we have our, and I know that it's a cubic, so I know the concavity, but we're going to find that anyway. So we're going to go over here and do the second derivative, which would be 6x. And that means, and set that equal to 0. And so I have 0. And 6x would be positive slope like this, so it goes from negative to positive at 0. So I have concave down from before 0 and concave up after it. So that means this is concave down, and then concave up, and I have a point of inflection at x equals 0, which is definitely what happened here. So there's my graph. That's the first one graphed.